Well, we'll go ahead and get started here. Again, welcome to the first webinar of kind of this series that we're doing. And this one is basically which unlicensed frequency is best for your application. And kind of what we've decided to do is based upon a lot of the questions we were getting both from the phone as well as conversations out in the field and different shows, as well as the analytics of where we see people looking on the page. We kind of developed a two-part series in which this will go for the rest of the year. But essentially what we're going to be doing is we're looking at kind of a little bit more of a higher view of things the first part of the month, and then we go into a little bit deeper dive into a webinar or a net lab into kind of the second part of this, and I'll give you a little bit more details with that that Eric will be doing. Really kind of the idea is to kind of get into the nuts and bolts and actually how to do some of these things that we're learning about. So as we kind of look at this going forward today, is as we start looking at the applications and the different types of scenarios and networking that people are doing, unlicensed frequencies are really now being applied across the board, but there's some mystery as to which one is going to be the best one and actually to do that. So as we kind of get forward, just to kind of get everybody up to speed of who the heck is Esteem, really who we are is we've been around since 1982 is when we were actually incorporated, went public in order to take an idea and turn it from paper into a product. It's been over 38 years now that we've been doing this, and we're actually the manufacturer, and this is all that we do. So we actually design and manufacture specifically for the rigors and the hardships and some of those conditions in industrial automation. As the manufacturer, what that also does is it grants us full ownership and control over the full IP of things. So we own everything from the hardware side as well as the software side. It allows us to control a little bit better that life cycle, also allows us to react a little bit faster. This is our product. What it also allows us to do is that we are very conscious of backwards compatibility. So our current products today are backwards compatible with the models that were out previously. And so as you start looking into some of these bigger applications, that really goes a long ways because this is a sizable investment, and we want to make sure that we can support this and you can support this and you can utilize this going forward. Everything is made here in the US, nothing is offshored. So in addition to kind of being, one of the few that are still made here in the States, it's also a big part of the security side of things. We know where this has been made. It's never been offshore. It's not coming from China or anything like that. What we've done is we actually have created 10 different products, probably the most comprehensive portfolio within the industry. We have FCC license frequencies, which are your 150 to 174, 217 to 220, 450 to 470, and 4.9 gigahertz. And we also get in, the majority of what we're doing now is the license-free frequencies. So these are your 900 megahertz, 2.4 gigahertz, and 5.8 gigahertz. That's really kind of the whole brunt of what we're going to be talking about today, are those unlicensed frequencies. Today, we've got a little over 45,000 modems in service worldwide, predominantly in the Americas, but we do stretch across the globe. And kind of where we really kind of find our niche is some of the major markets that we're involved with is the water, wastewater, oil and gas, mining, material handling, power and energy, ag. We do infrastructure and factory floor, as well as AGV use is really kind of coming on much stronger. And when we kind of look at this, when we start getting into the applications and the networking across these industries, we're really kind of seeing a common thing going on, especially within the industrial world. And it's all part of basically moving into what we call the digital transformation. You've probably heard about it, or different terminology that's used there. But really kind of where we're sitting now is right here in this industry 4.0. I mean, everything is now cyber networks. We're talking IoT. So we've really kind of now taken a fundamental shift going from a serial-based network, which was designed to be, say, a PLC to a PLC or a device-to-device level communications. So not only have we moved it into an Ethernet-based protocol, what that also is doing is in addition to changing the actual data structure itself, now all of a sudden everything is going into a network system as opposed to that point-to-point or device-to-device level communications. And that's a big part of it because when we start getting into networking, now all of a sudden it has some different requirements to it. It has a little bit different demands to it. So when we kind of start looking, in addition just to your basic networking there, a lot of additional items are being put onto those networks. We're dealing with IoT, we're doing AI, analytics, we're talking about IIoT convergence, we've got machine learning, we're doing predictive maintenance, we've got video cameras, we've got MQTT. We've got a lot of different, I guess, solutions all being put across that common network, and we've got to make sure that we build that network in order to be able to accommodate those. So we kind of look at that today's connected model. Really what we're looking at is really kind of 4 pillars of today's connected enterprise, or this connected network. So to start, we really kind of have the things. If you kind of look at this from on the left side of your screen there, these are things like your Rockwell devices. These are your PLCs, your HMIs, or your tablets. It's the things that are out there in the field. And we've got to basically be able to have some connectivity to them. We've got to be able to store that data. And then, the key part is what do we do with that data once that data is actually trapped? And so we need to be able to analyze that. And this is things like factory talk. Okay, so these are kind of the 4 pillars now of the common or today's connected model. Now, when we take that connected model and actually apply this into the industrial automation market or into some of these heavy industries, whether that be water, wastewater, oil and gas, mining, and so forth, there's a couple things that we have to deal with that are going to be a little bit different. And so in those type of applications, usually we've got unique challenges. We're typically dealing with longer distances. These can be citywide, countywide coverages. We're going across waterways, we're going across roadways, we've got mobile applications. Basically, we're dealing with a lot of remote assets. So really, when we get into these types of challenges, this is where wireless makes the most sense, right? So this is actually where we want to get into the meat of what we're talking about today. So when we start digging now in a little bit more into wireless, kind of the first question usually comes up is what's the best frequency to use? Well, when we start looking at wireless in general, there's not a good frequency, there's not a bad frequency, but what we find is that there's a right frequency and a wrong frequency for your application. Okay, so it's a balancing act. So basically every frequency has advantages, it has disadvantages. Kind of the key word to this is your application. We've got to kind of match this up to what you're trying to do. We kind of start looking at across those frequencies in that balancing act that we're talking about. We start looking at, and you can kind of see this graphic down at the bottom, is kind of build this within a ladder. And so in that 150 to 174 megabits or megahertz frequencies, these are those very low volume of data, but we need to get through a lot of line of sight obstacles or obstructions. These are the frequencies that penetrate the maximum line of sight obstruction. Typically, what the best rule of thumb is, the higher in frequency we go, the more line of sight dependent it is. Now, the other kind of the flip side of that is that the higher in frequency we go, the higher the data rate that we can achieve. So it's kind of this balancing act of where does it need to go. And so we're going to kind of look at that as we kind of climb that ladder, that 450 to 470. Again, this is one that's very common within the water wastewater market. This can also deal with quite a bit of line of sight obstruction. Then we start getting into the 900 megahertz. This is where we can start. This is getting into the unlicensed frequencies or license free. So this is where 900 megahertz can tolerate some line of sight obstruction. Of the unlicensed frequency bands, it's the most forgiving for line of sight. As we get up into 2.4, it can tolerate a minimal amount of line of sight obstruction. And we get up into that 5.8 and 4.9 gigahertz up here. And this is absolutely dependent upon line of sight. Those antennas have got to be able to see each other. If not, what we're going to have is a loss of communication there. So kind of a good analogy that a lot of people will use is when we're down on these low frequency, it wants to work more like a gas or a smoke and fill that area. As we get into these high frequencies, it's more like that laser light that we can shine. It is anything that it hits, it's going to now either to stop that or basically reflect that or scatter that signal, okay? So as we kind of look at these a little bit closer, is we've got these 3 unlicensed or license-free frequencies available to us. And these are the 900 megahertz, 2.4 gigahertz, and 5.8 gigahertz. That's really kind of where we're going to concentrate today. So really kind of the question is, okay, now I have 3 of these. Well, which one is going to be best for my application, or in this case, in your application? And that's really where it starts. And this is really kind of the crux of it, is we've got to look at your application itself. So when we start looking at that, really we look at this in kind of in a 3-dimensional puzzle. We're looking at the what. Now this is basically, what are you trying to do on your network? This is going to be, is this a serial network? Is it Ethernet? Is it something that's migrating from serial to Ethernet? Is it an IO control network? Are we going to have video on this? Are you envisioning having mobile clients or thin clients out there on your network itself? Are we dealing with a roaming vehicle that's out there, whether that be a work truck or an AGV? Do you want this to have Wi-Fi capabilities for whether for your workers or into an office or different location? So we kind of take that what is the first question that we really want to answer. Then we start looking at the where of this in that physical environment. And we really are looking at 3 things. One is the distance between those links. And so we've got to consider how far we're trying to do, but also what is that terrain made out of? Or what do we have to encounter? So if we have things like trees and hills, buildings, we've got to consider those items as well. Then we start looking at the RF environment and say we're dealing with unlicensed frequencies. So there's going to be other users out there, and that may come down to, maybe say, we're envisioning using 900 megahertz, but we need to move to 5.8 gigahertz just because it's too used up. So there's really the what, the where, and what that we're trying to do is to drive that to what's the best way to get this done, the how of it. And that's going to basically point us towards a frequency and the bandwidth that we're going to need for that application. And that's really kind of the appropriate technology that we're talking about. So to kind of step into this a little bit further now, is that we've got, as we kind of take these one by one, the 900 megahertz band, it's the 902 to 928. So kind of the advantages of 900 megahertz is, number one, it is license free. So there is no FCC licensing. That's something that the manufacturer gets. But this is the most forgiving of those license free frequencies. We can live with some trees. We can have some buildings, etc. Typically, we have a little bit better range to this. These are going to be your 5 to 10, maybe up to 12-mile links between locations. It is a non-Wi-Fi frequency, so a couple of things that does is it kind of stays out of probably the busier networks. If you're in an area where there's a lot of homes and home routers, it does also increase on the cybersecurity because we don't have any Wi-Fi access into this frequency. The other big advantage of this is all in proprietary communications. So there is no open standard. So it does, again, equal better security for that application. There are some boundaries to consider with 900 megahertz, is that because it is license free, is that you're sharing that with other users in the area. And so that can, whether you want to consider that a noise floor, interference, there's going to be other networks that we're going to have to coexist with. Kind of one of the pluses of it being a non-Wi-Fi frequency is also one of the disadvantages is if you want to have Wi-Fi technology or connect, say, your thin clients or a tablet device, now all of a sudden we can't do that at 900 megahertz because it just doesn't live within that. And so if you're doing, whether it's laptops or tablets or even Wi-Fi sensors, a part of the IoT, that's really not going to be utilized within the 900 megahertz. Other concern is depending upon which way you go is, does it have enough bandwidth or data rate to support the application? Right? So what we've also got here is going to be, does it also support the network architecture, the topology? How does this going to fit? So we kind of dig into 900 a little bit more, is it's really been kind of an evolving frequency. And so 900 megahertz itself has always been kind of the long-time workhorse of industrial automation. These have been your traditional frequency hoppers that probably everybody has got some experience with, really kind of what started the unlicensed band here. What we started to see is it started showing to be a little bit too slow for this digital transformation or doing video, because those older technologies were basically maxed out about 1 megabit per second. So it also had kind of a limited topology. It was kind of that master client or a hub and spoke type of topology that we could set up. Also, just due to the age of it, that it kind of had some substandard encryption. A lot of it doesn't have any encryption whatsoever, as well as there's a lack of updates for it. The other big problem that people were running into is there was no backwards compatibility for today's products with what they already had out in the field. So we started getting a lot of calls and a lot of requests for how do we take 900 megahertz and basically make it better? How do we make this to support today's applications? Okay, so what we did is we actually came out with what the esteemed Horizon 900. And kind of what you want to think about is this really kind of married Wi-Fi technology and 900 megahertz. You get the best of both worlds, because now all of a sudden we can run at 900 megahertz and actually get 72 megabits of data rate. So the way we did this is through what we call OFDM modulation, which is basically just how the data is spread and then sent or transmitted. This is the same technology that's used for your Wi-Fi. If you want to know what OFDM stands for, it's orthogonal frequency divisional multiplexing, which is a mouthful to say for sure. But really what it's doing is we're getting a nice wide band in order to transmit that data to give us higher data rates. This is where now all of a sudden we're not stuck in that hub and spoke type of topology. Now all of a sudden we can get into full-blown mesh technology, and we can have these redundant self-healing networks out in the field. We've got much better security with this, and we've got a full AES to it, 56 encrypted connections. And each device, and there's multiple different modes that we can put these in. We can be a straight bridge, we can get into routing, we can be an IP masquerading if you're familiar with the Linux terminology. We've got station modes, which are, say, clients that would be used for like a roaming capability, whether it's an AGV or a maintenance vehicle. What this does is it really allows it to be a very flexible network, but also very scalable, because they're not dedicated pairs. We could have 5 out there today and add 2 more, in a year from now. It does support either layer 2 or layer 3 connections. And then we also have mobile roaming. Okay? So we kind of look at this, and when we're dealing with wireless, sometimes there's a lot of confusion because we're dealing with the invisible. So to kind of put this in perspective, when we look at what a frequency hopper looks like, kind of the older technology of 900 megahertz, we really had these little sub carriers, and we'd put little bits of data across both of these or all these different channels and send it across. Now, when we go to this OFDM, what it looks like now is you can see it's a nice wide band here. And so this is where we can now all of a sudden we're moving from a highway mentality into a freeway mentality. We've got multiple lanes all going across simultaneously to give us higher data. So if you want to kind of look at, okay, what kind of size difference are we looking at? When we start looking in again, putting some clarity to these things, when you look at kind of those narrowband signals, they're basically, if you want to think about an eighth of an inch pipeline. We get into this OFDM signal that you use, whether on 900 megahertz 2.4 or the 5.8 now, is now all of a sudden we're moving that little stir straw into a 17-foot culvert. Okay, so we're getting more bandwidth. Now, why is bandwidth important? Because ultimately bandwidth directly controls that data rate, or allows us to get higher data rates. Okay, and so as you can see, those 20 megahertz wide channels now all of a sudden we've got a nice big pipe to be able to get a lot more data through it. So again, as we get into this Wi-Fi or into the 900 megahertz, we're now taking that 900 megahertz and using that OFDM modulation to give us this Horizon 900 that we just went through. So kind of shift gears now, says, okay, let's take a look at the 2.4 gigahertz. And this is kind of your traditional Wi-Fi, or kind of what started off in the Wi-Fi world. This is the same technology that's using on your home router. So again, it's license free, but now all of a sudden we can start going even faster. We can get increased data rates. We can do up to 150 megabits in real world conditions, because now all of a sudden that 20 megahertz channel, now we can get 40 megahertz. So ultimately we can go basically push twice as much data through this. Okay. Now, the other nice thing is that this can act not only as an access point, but we can also add bridge functionality to it to give us out that mesh network that not only connects those devices, but it also provides a canopy as an access point for your third-party devices, your tablets, your laptops, Wi-Fi sensors. Can we get self-healing mesh technology? Now, all of a sudden, we're moving also as we've got 11 different channels to choose from. So we can actually have multiple non-overlapping networks in that same area. Again, one of those things to consider is because it is license-free, there are going to be other users in there. So that the 2.4 gives us additional space in there to try and coexist. We do need much more line of sight. There is a bit more of cybersecurity liability just because we're now introducing Wi-Fi. So there's going to be some control that goes in on the network side. You want to make sure that you're using strong encryption, as well as what type, if you want to use a radius server for that encryption, we can do that. Also, because of the higher frequency, typically we have a little bit less range to this. This is your 5 to 7 miles. Again, this is between locations. Because this is a mesh radio, you can think of it as anybody as a repeater for anybody else. We kind of take a deeper look into the Horizon 2.4, which is what Esteem puts out. Again, we have the same industrial mesh technology that enables the redundant self-healing and a scalable network. Same multiple modes of operation that we can do in any single radio. So we can put these into an AP bridge mode. We can go into a router mode or a masquerade or the station modes. We can, again, do layer 2, layer 3, as well as those connections are AES-256 encrypted. Very simple configuration in that we can actually encrypt or basically configure these radios, whether we're using the onboard web page or into a Java-based utility. Now, we've also got kind of a memory module within this. The idea is kind of the same as your SIM card technology. We can pull that memory module or little SD card out if we have it configured, put it into another one, and clone that radio. So if we have an event in the middle of the night at a different time, or we can use it for rapid deployment. What you see is now all of a sudden we're getting that 150 megabits and gaining Wi-Fi to it. Okay, so we kind of go further up the ladder. Is now all of a sudden we're looking at 5.8 gigahertz. So this is again within those license-free operation. Now all of a sudden we're now going even faster. We've got up to 300 megabits per second in real-world conditions. And really, because what we're doing is we're employing MIMO technology, and we've got dual 40 megahertz wide bands that are running simultaneously. One of the other things is to kind of keep in mind with this is one of the things that separates the 5.8 a little bit differently is that there's 17 different channels of operation there. Only 5 of those are used for Wi-Fi. So if you want to bring Wi-Fi technology in for your tablets, we choose one of those 5 channels. If we want to kind of isolate ourselves and we're only using this, say, for a SCADA network in which we don't want to have Wi-Fi access to it, now all of a sudden we can now put it onto some of the non-Wi-Fi channels to isolate ourselves from that noise, but also to make it a little bit more of a secure network. Okay. One of the things with 5.8 is it does require absolute line of sight. These antennas need to see each other. Anything that gets in between them is ultimately going to kill that link. Okay. Again, the higher the frequency is, and those higher data rates require more signal. And so our range is down to about 3 to 5 miles on this. So again, it's not necessarily a good thing. It's not necessarily a bad thing. It's just something to be aware of as we're designing that network. So we start looking at it. This is where we have our Horizon 5.8. Again, we get that same industrial mesh technology, single device with multiple modes, layer 2, layer 3 networks that we can go in and support. AES-256 encryption, same simple configuration options that you can do there. And then we've also got the same memory module for rapid replacement or rapid deployment. Probably the big difference here that you see is that we're getting within that MIMO technology is now we can get up to 300 megabits per second. So if you're doing an application that requires much more speed, something that's very, very video intensive, or some of the IO control networks, or even getting into some of those devices which require a little bit faster updates, or we have more devices on that same network, is really where we want to start looking at that 5.8. So again, kind of what we've looked at now is within those frequencies. Again, we want to take the what, we're going to now blend it with the where, and then give us the best how on this application. And kind of the idea of this is ultimately is to try and keep these sessions down to that 20 to 30 minutes. And so to kind of give you a cheat sheet, and if this might be something you want to take a screenshot of, or something that this will be available as well, and you can let me know and I can actually get you the slides as well. If we want to kind of look at those, kind of a cheat sheet of those 3 different frequency bands and where would they fit, is basically 900 megahertz, better range, longer distances, best flexibility on the unlicensed bands, it's non-Wi-Fi, and it's proprietary communications. The 2.4 gives it a little bit more speed. We've got wider channels. We can live with a little bit of line of sight obstruction. We've got limited brand interoperability versus everything being a proprietary system. So you can come in as an access point to a client into different brands. We have third-party devices via Wi-Fi. 5.8 gives us that highest achievable data rates. It's intolerant of line of sight obstructions. We've got limited brand interoperability as well, and then we can also bring on these third-party devices. Kind of see that little graphic on the side. Just kind of remember, everything is a scale. In order to get something, we're going to give something up. And so finding that right blend of that. As I kind of mentioned when we started this, is that we're going to be looking at this a little bit more in depth of how do we now take that knowledge and start designing that network. And we're actually going to have a net lab in 2 weeks on Wednesday the 28th, in which Eric is going to go through some of those RF design considerations. And this is going to be a little bit more hands-on. It's going to be something of how do you take those things and start putting this into a design of a network. So great one there. You can find the link on that on our website as well, so that you can kind of continue this education. Again, this is something we're going to be doing for the remainder of the year. We're going to continue to build up. You'll see all those different, webinars and net labs up on the website, as well as you can watch kind of for the social media side of things to kind of announce what it is. Now we've got a few minutes here before I'm going to turn you loose. If there's any questions, feel free to ask them here. You can shoot me an email. You can give us a call. Anything that way. Not sure if anything is coming in there. All right, well, I want to thank you everybody for joining us today, and I look forward to continuing in this journey with you as we go throughout the rest of the year, and have a great day.